warning you about drifting lanes, to vehicles that practically drive themselves in certain situations.
Ah,
It's a whole new world.
it is. And most of that progress, as you said, it relies on sensors that see what's directly in front or around the vehicle.
Yeah, the cameras, radar, LiDAR, they're amazing at what they do, no question.
But what's truly revolutionary is imagining a vehicle's awareness extending far beyond what those line-of-sight sensors can ever detect.
Okay.
What if a car could know about, say, a child about to dart out from behind a parked truck maybe 2 blocks away,
Wow.
or understand the exact status of a traffic light even before you, the driver, can see it?
That's precisely what we're diving into today, isn't it? We're
Huh.
talking about this foundational technology,
Mm.
sort of operating behind the scenes,
Mm-hmm.
one that's actively extending a vehicle's perception far beyond its immediate line of sight. It's called V2X roadside units, or RSUs.
That's right. Think of them as these crucial, often invisible pillars of intelligence and safety being built directly into our road infrastructure.
Pillars of safety, I like that.
And our mission really for this deep dive is to unpack what these RSUs are, the profound safety benefits they offer to all road users.
Right, not just the cars.
Not just cars, pedestrians, cyclists, everyone. And crucially, we'll explore the intense engineering rigor that's building, well, immense confidence into these systems,
Yeah.
making sure that for life-saving information, reliability isn't just a feature, it's the absolute bedrock.
Okay, let's unpack this seeing beyond the horizon idea a bit more. We've all seen the flashy demos, self-driving cars, spinning LiDAR sensors.
Zero.
But our source material makes a really important point.
Mhm.
While cameras, radar, LiDAR are incredibly powerful, V2X is actually the only sensor that can extend a vehicle's field of view beyond line of sight
That's
and even share the intent of other road users.
Mhm.
That's not just a game changer. It fundamentally redefines what a smart vehicle can perceive.
It truly does. And if you connect this to the bigger picture, V2X isn't just another sensor, it's more like a secure, ongoing conversation.
On conversation.
Yeah, a network where all equipped road users, cars, trucks, motorcycles, the RSUs themselves, and, eventually maybe even pedestrians, are continuously sharing vital data.
Like what kind of data?
Their location, speed, direction, and crucially planned actions like turning or braking. This secure collective awareness builds a real-time understanding of the whole road environment.
Something no single car could do alone.
Exactly. Something its onboard sensors could never achieve by themselves.
Okay, this sounds incredibly powerful.
Mm.
Almost like the road infrastructure is getting its own nervous system.
That's a good way to put it.
But if vehicles are going to rely on this data, it raises a massive question for me. How do we know this information is always dependable? How do we trust it?
That raises an absolutely critical point. For this entire system, this whole conversation, to truly work, the information flowing from an RSU must be, well, unquestionably trustworthy.
Okay.
The stakes couldn't be higher. I mean, imagine a vehicle acting on compromised or just plain wrong data.
Yeah, the consequences.
The consequences could be catastrophic, right?
Yeah.
Directly impacting safety on our roads. The future of truly autonomous driving might hinge not just on what the car itself sees, but on its absolute unquestioning confidence in, like, an invisible signal from a roadside box.
Wow.
If that confidence is ever compromised, the entire system just unravels.
That really puts it into stark relief. So, okay, what does this dependability look like in action? Let's maybe look at some real-world safety services powered by these RSUs.
Good idea.
Understand the benefits, but also the inherent risks they have to manage. Let's start with traffic light phase, often called stat messages, right?
SPAT, yes. Signal phase and timing.
How does that actually work at, say, a busy intersection?
Okay, so you have an RSU, and it's hardwired directly into the traffic light controller.
Physically connected.
Physically connected, and it broadcasts messages with the current light phase, red, yellow, green, and the precise countdown, like the time remaining until the next phase change.
So the traffic light is basically talking to the cars.
Essentially, yeah, it's like the traffic light itself is politely telling every approaching equipped car, here's exactly what I'm doing and what I'll do next.
And the benefit. How does that help me as a driver or an automated vehicle?
Well, for you, a driver assistance system in your car could maybe suggest an ideal approaching speed, help you time the light perfectly, avoid unnecessary stops or sudden braking.
The green wave idea.
Kind of, yeah. And for an automated vehicle, an AV, it enables optimal, smooth navigation through the intersection because it knows the light status well in advance.
Makes sense. But what's the risk?
Okay, here's the critical challenge. If a malicious actor, a hacker, were to somehow falsify that traffic light status, or even if the RSU itself just malfunctions, maybe a glitch, it could lead to a wrong notification for you, the driver, or worse, tell an automated vehicle to proceed through a red light.
That's bad.
It's very bad. So the receiving vehicle must have the ability to detect a cyber attack, and the RSU itself must be capable of identifying its own failure and basically shutting up, ceasing transmission to prevent danger.
Wow, okay. That really shows the level of confidence needed. What about another one? Collective perception. This sounds like the RSU is acting as an extra sort of all-seeing eye for the road.
That's a great way to think about it, precisely. In this scenario, an RSU is equipped with its own local sensors, maybe high-definition cameras, machine vision.
Its own eyes.
Its own eyes, yeah. And it uses them to detect pedestrians, cyclists, other road users, especially those a human driver might easily miss because of obstruction.
Like parked cars or buildings.
Exactly, things blocking your view. And then it broadcasts this critical information to surrounding vehicles.
So the benefit is clear. My car could warn me about that kid about to run into the street from behind a delivery truck. Or an automated vehicle would start braking even before the child is visible to its own onboard sensors. That's huge. But what's the unexpected challenge here?
Well, the challenge is also immense. If that RSU sends false information, maybe it's a sophisticated cyber attack, maybe it's a rare malfunction, a sensor glitch.
Okay.
It could cause a driver, or more critically, an automated vehicle, to initiate unwarranted braking.
Slamming on the brakes for no reason.
Exactly. Imagine that happening suddenly on a crowded highway. It could create an immediate and dangerous road hazard, potentially leading to a pileup.
Right, a chain reaction.
This is a very real concern engineers have to meticulously design against.
Okay. And finally, the third example. In-vehicle signage, IVI messages. I could definitely see the immediate benefit here, having speed limits or, road closures displayed right in my car, especially if visibility is bad.
Absolutely. So RSUs send information about existing signs, both fast ones and dynamic ones, like the current speed limit, upcoming road closures, maybe even unexpected hazards like black ice warnings.
That's very useful.
The benefit is profound. If your vehicle detects you're violating a safety-critical sign, like speeding in a work zone,
Yeah.
the system can immediately inform you, the driver. Or, for an automated vehicle, it could even trigger an appropriate safe action, like gradually slowing down.
But I'm guessing there's a but.
There's always a but with safety systems. Just like the other services, compromised content in these IVI messages, again, maybe faked by an attacker or due to a fault, it could lead to unwarranted braking or other dangerous situations.
Like an autonomous car suddenly slowing down on the highway for no real reason.
Precisely. Because it thinks the speed limit just dropped drastically based on bad data.
Okay. So we've established why confidence or trust is so critical. But how? How do you actually engineer that kind of unwavering reliability into a system that's constantly broadcasting potentially life-saving information?
Right.
This is where the source material gets really interesting. It talks about two main pillars: functional safety and cybersecurity. Let's start with functional safety, designing for malfunctions. What's the core goal here?
Okay, functional safety. The objective here is to meticulously analyze every conceivable scenario where a system malfunction could lead to a dangerous outcome for road users.
Every scenario. That sounds daunting.
It is. It's about proactively identifying potential failure modes and designing the system not just to prevent them, if possible, but crucially to manage them safely if they do occur.
Managing failure safely.
Exactly. A key metric here is ASIL. That's Automotive Safety Integrity Level.
ASIL, okay.
And for RSUs, the goal is often ASIL B. Achieving ASIL B represents an incredible level of engineering rigor. It's vital because hitting ASIL B allows a vehicle to confidently apply its brakes or take other significant safety-critical actions based purely on the messages received from that RSU.
So ASIL B isn't just like a letter grade on a report card. It means like a 1 in a billion chance of dangerous failure.
The probability targets are astonishingly low, yes, often measured in failures per billion hours of operation. It signifies that deep level of engineering and validation. That's the bedrock that allows a vehicle to truly rely on that RSU signal for critical maneuvers.
Can you give us some concrete examples, like specific safety goals and how they tackle potential engineering problems?
Sure. One critical goal is message integrity, and that targets ASIL B. This means the RSU must instantly detect any modified content in a V2X message.
Any change at all?
Any change. Whether it's a subtle memory error, maybe a bit flip caused by solar radiation hitting a microchip, which sounds weird but happens,
Wow.
or a deliberate malicious manipulation by an attacker, detection has to be immediate.
Okay, what else?
Then there's operating V2X link. That's typically ASIL-A. This is about ensuring the RSU can detect failures in just transmitting or receiving messages, maybe physical damage to the unit, or even just a poorly mounted antenna after installation.
Right, basic function.
Basic function, but critical. We also need to assure data exchange integrity, often ASIL-B. This means detecting corruption in data the RSU receives from, say, that traffic light controller we talked about.
So the input data needs checking too.
Absolutely. That data link could be affected by physical damage, weather, even electromagnetic interference from nearby power lines or something.
And the software itself. The brains of the RSU must be equally dependable, I assume.
Absolutely. That's software execution correctness, another ASIL-B goal. Detecting failures in the RSU's own software flow, maybe unexpected memory issues, unhandled exceptions that could crash the system or cause it to behave unpredictably.
Okay.
And finally, related to security, the security subsystem functionality for the signing process itself, maybe ASIL-A for that part, ensuring the security mechanisms themselves don't fail due to, again, maybe memory bit flips or EMI affecting the crypto chip.
That is comprehensive.
And the crucial point for all of these is that any failure detection must be rapid, like almost instantaneous. And the system must immediately transition into a predefined safe state to prevent any risk to road users. Usually that means just stopping transmission of potentially bad data.
Just go silent if there's any doubt.
Better safe than sorry, essentially.
That sounds like a truly exhaustive process. And the source mentioned something really clever. The RSU's ASIL rating, its achieved safety level, will actually be included in its V2X messages. What does that mean for the receiving vehicle out on the road?
Yeah, that's really important. It's all about transparency and enabling intelligent decision-making in the vehicle.
How so?
The receiving vehicle immediately understands the functional safety capabilities of the RSU it's talking to. It knows its proven level of reliability based on that ASIL rating.
So the car knows how much it can trust the RSU.
Precisely. This allows the vehicle systems to assign a proper level of confidence to the incoming information and make a highly informed decision about what actions it can safely take based on that data. For instance, deciding whether to just issue a driver warning, which might be okay with slightly lower confidence, or confidently initiate an automatic emergency braking sequence, which requires that very high ASIL-B level of trust.
Okay, that makes perfect sense. So functional safety tackles malfunctions and engineering for extreme reliability. What about the other pillar, cybersecurity, making absolutely sure the data is authentic and hasn't been tampered with by an external threat like a hacker?
Right. This is where digital signatures come in as a really fundamental safeguard.
Digital signatures, okay.
Each V2X message sent by an RSU is digitally signed in a unique way. This is done by something called a secure element.
A secure element.
Think of it as a tiny tamper-proof vault or chip inside the RSU. It's specifically designed for highly secure cryptographic operations, like creating these signatures.
So it's like a hardware root of trust.
Exactly. And this signature it creates is so precise that it makes it effectively impossible to change even a single bit in the message without the receiving vehicle immediately detecting it.
Instant detection of tampering.
Instant detection. It's like a unique, unforgeable digital fingerprint for every single piece of information broadcast.
Okay, but how does my car know to trust that specific digital fingerprint? Couldn't an attacker just make up their own RSU with its own signature?
Great question. That's where certificates come in. The digital signature also incorporates the RSU's unique certificate, and that certificate has itself been digitally signed by a trusted certificate authority, or CA.
Like a digital notary public.
That's a perfect analogy, a highly reputable, trusted entity. The vehicle trusts the CA vouches for the RSU certificate, and the certificate validates the signature on the message.
A chain of trust.
Exactly, a chain of trust. This entire mechanism ensures the RSU's authenticity and completely prevents anyone from manipulating the message content or impersonating a legitimate RSU.
And I assume this isn't just something companies decide to do.
Oh no. This digital signature mechanism is so critical that it typically requires approval by national or regional authorities and often formal certification by a neutral third-party evaluator before these RSUs can be deployed on our public roads.
Rigorous validation.
Okay.
Now, this brings us back to those dual brains you mentioned earlier, the safety domain and the management domain within the RSU.
Mm-hmm.
Given all this talk of rigorous functional safety, ASIL levels, and cybersecurity,
Mm-hmm.
why is it so incredibly crucial to keep these two domains isolated from each other?
This is perhaps one of the most vital cybersecurity and safety considerations for RSUs. It really bridges both worlds.
How so?
The management domain, remember, that's the part that connects to remote servers, maybe a traffic management center, and often accesses the public internet via, standard consumer-grade cellular modems.
Right, connection to the outside world.
That domain is naturally exposed to a much wider array of complex, constantly evolving security threats, just like any internet-connected device.
Right.
The safety domain, on the other hand, is purpose-built just for that short-range, safety-critical V2X communication. It's constructed using automotive-grade components, automotive design principles, focused purely on safety and reliability.
So if I'm getting this right, the management domain is kind of like the internet-connected front office, potentially exposed to all sorts of digital risks.
Yeah.
While the safety domain is like the highly secured, isolated vault or server room, purely focused on the critical safety operations.
That's a perfect analogy. Absolutely spot on. And to prevent any vulnerability or attack in that more exposed management domain, the front office, from ever impacting the critical safety domain, the vault.
We need walls.
You need strong walls. Strict isolation is absolutely crucial. This is achieved through a combination of physical separation between components where possible and very clearly defined, highly protected logical interfaces between them. It's about putting up impenetrable barriers.
And you mentioned this also ties back directly to functional safety, to those ACL ratings, right? How does that work?
Exactly. From a functional safety perspective, that management domain, the front office, would typically have a much lower ASIL rating, maybe ASIL A at most, or often just QM, which means standard quality management, basically no specific safety requirements.
Because its failure isn't directly dangerous.
Right. Its failures don't directly lead to safety hazards on the road in the same way the safety domain's failures could. So to achieve those high ASIL A and ASIL B ratings in the safety domain, engineers must demonstrate independent operation.
They have to prove it's separate.
They have to prove unequivocally that a failure or a cyber vulnerability in the non-safe management domain cannot possibly impact the safety-critical safety domain. This deep physical and logical isolation is precisely what allows the safety domain to maintain its extremely high ASIL ratings.
And therefore be trusted.
And therefore be confidently relied upon by vehicles for critical actions like braking or avoidance maneuvers.
Wow. This has been a truly eye-opening deep dive into a technology most of us have probably never even heard of. Yet it's clearly poised to fundamentally transform how we interact with our roads. So just to recap quickly, V2X roadside units, RSUs, are actively transforming road safety by extending vehicle awareness far beyond what's physically visible.
Seeing around corners, essentially.
Seeing around corners, predicting traffic flow,
Right.
and building that profound confidence, that trust into these systems isn't just a nice to have. It's absolutely essential.
Yeah, negotiable.
Achieved through that combination of rigorous functional safety design, aiming for high ASIL levels, robust cybersecurity using digital signatures and certificates, and that strict domain isolation between the RSU's core function.
You've got it. And thinking ahead, this foundational layer of highly dependable, constantly communicating road infrastructure, it's going to shape so much more than just preventing accidents, as important as that is.
What do you mean?
Well, consider how this invisible infrastructure will influence everything from urban planning, how we design cities, manage traffic flow in smart cities,
Interesting.
to accelerating the deployment of truly autonomous vehicles because they can rely on this external information and, fundamentally changing our daily commutes, hopefully making them safer and more efficient for decades to come.
So it's not just about safety, it's about the future of mobility itself.
It really is. It's an exciting future being built, one trusted message at a time.